Assalamualaikum warahmatullahi wabarakatuh and good day again everyone. So now we will start our first chapter in Geotechnics about the soil stress or stresses in soil. Okay, I hope you still remember the how we address the soil weight or the stresses in the soil. Okay, so we can see here. Usually, we address the soil stress in the total or effective stress, and we also address the water that we have in the soil as a pore pressure or pore water pressure for more details for recognition. Okay. Okay. Basically, there is two sources that induce the soil to have stress. So first one is their own self-weight. So basically we call them as a geostatic stress due to this the soil self-weight of the soil mass. And second one, the stress also induced from the uh, outsourced factors such as structure, um, walls, big building, tall building, water, and so on. So all of them is called as a SS stresses. So different stress will give different stresses induced in the soil mass. So basically we have a vertical one and also lateral one. Okay, so this first part of chapter 1 will cover the vertical stress. So vertical geostatic stress usually increase with depth. And there are three types of geostatic stress, which is the total stress, gamma, and effective stress, gamma prime, and for water pressure, U. Okay, so total stress is effective stress plus for water pressure. We can also write down as a symbol gamma total equal to gamma prime plus U. If you still remember, I'm not sure. Okay, this slide explain the stress calculation, how the stress is count in the soil manner. So basically, we usually have a unit weight of soil, gamma, or density of soil, rho. So if you still remember stresses, wait, so stress, kakak sikit. Okay, stress equal gamma times height, and um, alternatively it also can be calculated from the density also times the height. So this is density. If we know the density of the soil, also we can calculate, and the unit is kilogram per uh, oh, kilogram per meter. And for this one, the unit is kilonewton per meter, meter cube. Meter cube. And the depth or the thickness of the ground surface can be measured from the ground surface. So the deeper it goes, basically the higher the stress. The deeper it goes, the higher the stress. Similarly, the bigger the unit weight of soil value, usually it's only around, it can be around 15 or 16, 17 to 18. But If we have a saturated soil, it can goes up to 2022 for the gamma saturated, gamma set. Yeah. We have a different types of gamma. It can be gamma bulk. So gamma bulk is the soil condition that combines uh, dry and also uh, s- um, wet of soil, slightly wet, not too wet. But for saturated, if you still remember, if I could draw somewhere here. Okay, okay. If I could draw again, soil basic properties. So I hope you already taken the soil mechanics. So we know that in soil we have air and we have water and we have solid. So for the soil that fully saturated, saturated. So basically they only have solid and water. The voids or the air condition in the soil is already filled up with the water, so saturated. So that's why gamma for saturated is usually much more bigger, But for the condition of gamma bulk means they still have some air pods or voids in the soil. They also have water. They also have solid. So combination of dry and wet. So usually it's around 15 up to 18 of the gamma. And however, for the gamma dry, we also have one more condition, gamma dry. So gamma dry, how we want to draw the phase diagram. So this is called phase diagram of soil. So for dry soil, so basically they only have solid and they have a lot of air, or I would like to wrote down as a void. Ada banyak lompong kalau bahasa Melayunya lah. In Malay, lompong, lompong. But means airports, a lot of voids. So this is dry condition. And this one is bulk condition. Normal condition, three-phase diagram. Bulk, B-U-L-K, bulk condition. So that's a few types of gamma and will lead to different value of stress. So the depth and the gamma will affect the value of stress. So total normal stress is generated by the mass of the soil body. So we assume the soil is continuum and we calculate by sum up the unit weight of the materials multiplied by the soil thickness of the or the depth. And as it is a vertical condition, so we can sometimes denote as only stress or stress sub V means stress of vertical. Sometimes also when we calculate thoroughly again, we can also call them as a pressure at initial condition, P0, pressure at initial condition. So these terms you will find again when we want to calculate the consolidation later in chapter 2, P0, initial state of the stress of this certain site. And the unit weight of soil is in natural condition and the water influence is ignored. Total stress. Okay, so let's see example. So we can see here, this is 3 different soil layer with a depth of 3 meter for soil A, for first soil, 4 meter depth or 4 meter thickness for soil number 2, and 4 meter thickness also for soil number 3. And both of soil 2 and soil 3 have similar gamma 18 kilonewton per meter cube. Whereas for the soil number 1 is lesser, 17 kilonewton per meter cube. So how we want to solve this problem? So usually we define first what the questions. So the question asks for the total stress at the depth Z, at point D. So they're interested in the middle of the layer, the third layer of the soil, in the middle of the third layer of the soil. So what is the stress? So usually when we want to calculate the soil stress, so we basically have an idea of triangle of the soil. So this is stress for induced in the soil number 1. Additional stress induced due to the soil number 1 and also due to soil number 2. And similarly, additional stress induced due to soil number 1, soil number 2, and soil 3. So how to calculate? Okay. So this is the simple manner to calculate the soil stress. Just time the gamma and with the height. So at A, we can calculate 17 times 1 meter, 17. Gamma B, 17 times 3 meter, so 51. So this point in the triangle is 51. Next, we got 123. I think this and D 159. So take your time, try by yourself how to calculate and adding all the stress calculation layer by layer. Or if you want to later on, I will show you. We also can have a speed calculation types to get the stress at D later. Okay, let's continue for the explanation of pore water pressure. So pore water pressure is pore pressure at a given point that has been induced by the hydrostatic or water, due to the water. So this time we are not using the gamma bulk or gamma saturated, but we use the value of gamma water. So the unit weight of the water. So in unit weight, so the unit is kilonewton. So it is 9.81 kilonewton per meter cube. Or simply we also can denote as 10 kilonewton per meter cube. And times with the height of the water in the soil. Let's say this is a soil and the water table is there. So if we knowing the height from here, so and the total depth of the soil, so we can have the height of water. We can have the height of water. So we can later finally can have the U value, the pore water pressure value. Okay, for the pore water pressure, there's sometimes also come across with the saturated or negative condition of the water. This is groundwater table, starts the maximum of groundwater table. However, some portion of here also indicate existing of water. So this part is called to have a negative pore water pressure. Negative pore water pressure. The below water that covers the soil below of the groundwater table is called positive pore water pressure. Positive pore water pressure. Okay, for the effective stress, it is a soil stress which not influenced by any water pressure, and that's why the calculation is effective stress, the stress prime, minus the total stress minus the U. The total stress minus the U. In next video, we will discuss more why we need to know the effective stress, total stress, and the pore water pressure and their application in different cases of the soil. So that's all for today. Assalamualaikum warahmatullahi wabarakatuh and thank you.